Welcome to CW 1.7. Today we're going to be talking about how to analyze a polynomial function. I'm going to show you the basics of graphing, but know that for your homework and for today's class, we're actually not going to graph them. So we're going to first start talking about, I want to graph this function right here. F of x equals x squared times x minus 2. The first thing we're going to do is this. Find the zeros and multiplicities. And I'm going to write these steps out for you on a test or quiz normally, and also on your homework it'll be laid out like that. So for now, number one, find the zeroth multiplicity. So z, look right here, if I can see if I plug in 0, I get 0. I can see if I plug in 2 right there, I get 0. So 0 and 2. For multiplicity, I'll write underneath. I can see there's a 2 on that x. Therefore, the multiplicity there is 2. I can see there's a 1 right here. And that means that multiplicity is 1. So 2 and 1 are my multiplicities. Now from there, we're going to go into something called touch or cross. So for multiplicities, or for multiplicity, two things can happen. It'll touch or it'll cross. Now what that means in terms of our graph is that on the x-axis, so if you imagine this is the x-axis here, touch is like a parabola, meaning like it'll lightly just like touch it once and bounce back up like that. Cross is going to mean it literally crosses through the axis, so something like this. That's your cross. Now what's really cool about this is if you look at this shape, this touch, that looks like a parabola. And that's actually on purpose. So a touch happens anytime you have an even multiplicity. This cross here is like a line. That happens anytime you have an odd multiplicity. So if I look here, notice how my 2 is even. We're going to write T for touch. This 1 is odd. We're going to write C for cross. Now for now, don't worry too much about exactly what that looks like. It'll come together as I start drawing the graph. For now, just remember, even means touch, odd will mean cross. So now step 1 is done. Step 2 is going to be, we're going to find the max turning points. So TP, I'll write that out for you. Max turning points and the degree. So the max turning point is new, but the degree is not. That's from last class. So degree, if we look at this thing, we see x squared right here. We see an x. If I were to multiply that, that would make x to the third. So our degree is clearly 3. That's not too bad. Now the max turning point is going to be something new. That basically means what's the maximum amount of times the graph can turn. So for example, if I show you a parabola, this point right here is a turning point. The turning point here would be 1. And notice how this is like a typical x squared graph. So notice how this 2 goes to a 1. I can draw x cubed graph like this. That's like a normal x cubed graph. I can see there are 2 turning points here. So there are 2. And then we can see that, again, that's an x cubed graph. So that 3 became a 2. So an easy way to connect all of it is we're going to write degree minus 1. That's going to equal your max turning point. And that's going to be very helpful for test quizzes, so make sure you guys put a box around that. So for this one, I can see my degree is 3, therefore my max turning point is going to be 2. Okay, so far we have find the zeroth multiplicity, 2 is our new stuff, max turning point degree. The final thing to do is going to be leading term and end behavior. And I know this is a lot of stuff, but don't worry, we're going to practice it today, so it will become more fluid the more we practice. The leading term is what we worked on last class. That just means the term at the very front once you multiply it all out. So here I can see x squared and x. I can also look at my degree. Your leading term is positive x cubed. Now, end behavior is simply referring to what happens at the end of a graph. So if I look at this graph here, x squared, the end behavior is referring to these points, this one and this one. Notice how they're both going up. Here's a typical x cubed graph. Notice on the left it's going down, on the right it's going up. So over here, you'll notice a chart. So if you want, you can pause the video here and just copy down this chart. This is called the end behavior chart, and it's basically a chart that maps out everything that could happen with end behavior. So the term we're going to analyze is a x to the n. Okay, that's our term. So this one simply means a is positive. That's what it means to have a is greater than 0. And this right here means n is even. So an example of this would be like x squared. And if you have positive x squared, the end behavior is up, up. So imagine a parabola in your head. On the left and right, it's both going up. This one right here, a is less than 0. That would mean a is negative. So the example would be negative x squared. So just imagine these. If it's negative, you just flip it. So it's down and down. Now we keep going, and it's odd and positive. So let's think of positive x cubed. Imagine that graph should look something like this. That's what we did earlier. So we're going to go down and up. And again, we're referring to simply what's happening at the left and the right of the graph, the far left, far right. So write negative x cubed over here. If it's negative, simply flip everything. So it's going to be going up and down. So that's our end behavior chart. And now we can answer the question, the leading term in end behavior. That's why we have leading term, because now we have the end behavior. This is positive x cubed. So that's this one right here. That's a positive and an odd number. So end behavior is down and up. So I know that's a lot of information, and I'm going to put it together right here. So remember, for today, we're not going to be graphing for your homework. I'm going to show you the graph though to make it help have more context in your head. So I'll sketch the graph for you. And again, we'll do this later. End behavior is down and up, so I'm just going to draw my down and up arrow. The zeros are 0 and 2, so that means I know my 2 points are there. Multiplicity, notice how on the 0 it's 2. That means as I approach 0, I'm going to touch it. So I'm just going to bounce right there. And then the multiplicity on the 2 is odd, which means I'm going to go through. And I'll just move that arrow to make it a little nicer. So that's a rough sketch of this graph. And that's how it all kind of comes together. But again, we're not graphing today. We're just going to practice finding the information. So let's try it again, right here. Step number 1. And hopefully at this point, you remember step number 1. We're going to find the zeros and multiplicity. So the zeros here, negative 1/2, 3. The multiplicity is going to be 1 and 2. Look at the exponents here. If you want, you can draw in a 1 to help you. Now you put that in context. 1 is even, 2 is odd. So you're going to write C or cross and T or touch. That's step number 1. 2 is our degree and max turning point. So degree, just imagine you multiply this out. That's going to be 2x from here, and this thing will make an x squared. So 2x cubed, that's right there, your degree, 3. Degree minus 1 is max turning point, so we're going to write 2. Step number 3, our leading term. Well, that's great because we did that right here with degree. Just put the 2x cubed right there. And then our end behavior This is a positive 2. This is odd, so look at our chart. Right here. Down, then up. And again, we're going to practice this process today, so it will become more and more fluid. By the time you get to your homework, this will feel very comfortable. Here's the last question. Which of the graphs could be the graph of a polynomial function? For those that could, list the real zeros. State the least degree the polynomial can have. So for this one, all of you highlight polynomial function. The key for a polynomial function is it must be smooth and continuous. Smooth and continuous. So for example, continuous means there's no break. So right here, there's your break. So this is not continuous. So this one is not a polynomial function. I'll put a sad face. This one is smooth and continuous, so this is fine. I'll put a happy face. This one right here is continuous, but is not smooth. There's a jagged edge right there. We can't have an edge in a polynomial function. So that makes it not a polynomial function. And then this one, we can see it is smooth and continuous, so I'll put a happy face. Now it says for those, we're going to list the zeros and the least degree. So let's start with the zeros here. I have -2, 1, and 2. This one I have -2 and 1. And that's just taken from your x-intercepts here. Now this is interesting. Least degree. We haven't really talked about that yet. So what we're going to do is think about this. Over here, we said degree minus 1 is a max turning point. So let's rewrite that. Degree minus 1, that is equal to your max turning point. So if you look at this thing right here, there are 2 turning points here. 2 turning points. So if we look at this formula, degree minus 1 is max turning point. Therefore, your turning points plus 1 are going to equal your least degree. So for this one, there are 2 turning points. Your least degree is going to be 2 plus 1, which is 3. For this one, I can see 1, 2, 3 turning points. So our least degree is going to be 4. And the reason it's least degree is because if I simply told you I have a graph, it's a parabola. We learned earlier that this could be x squared, x to the 4th, 6, 8, and so on. But that's why we're saying least degree. We can see there is 1 turning point right here, which means for this graph, the least degree would be 2. And that's how we're seeing that right there. Okay, so if you have any more questions, please ask in class, and then we'll practice some problems.